Okay, so here is the screencast for 3.5a, and it is derivatives of sine and cosine. So to start, we're going to put in our calculator sine x. So sine x, and make sure that your calculator is in radians, not degrees. And just to help you with graphing a trig function, if you choose zoom and choose the trig feature, it will make the window trig friendly. So it'll go from -2 pi to pi. So I'll hit 7. All right, so there is the sine function. And so what we're going to do, we're going to graph the derivative of the sine function. So to graph the derivative, I'm going to go back to y equals, go to y2. I'm pushing math and choose number 8. So now it says n derive. To recall the y1, I could either type in sine x here, or just to remind you how to put the y1, I hit vars, which is right here, the right arrow to y-vars window, choose function, and I'm going to choose y1 since that's where sine of x is. Then comma, which is right here. In terms of x, for all x, and then close parentheses. Now I'm going to graph. So this new one is the derivative graph. And if you recall from doing families of functions, this new graph that you see here is actually the cosine of x. So the derivative of sine is the cosine of x. Now the difference is if I do this with sine, so cosine, so let me put cosine in here instead, and then graph. So here's my cosine function, and now I'm going to graph the derivative of cosine. Now it does look like sine, but a little different. See, sine does go through 0, 0 here, but notice that I'm going down first with my curve instead of going up first. So that just means that the derivative of cosine is negative sine. And these are two that you have to memorize. All right, here's example 1. Find the derivative for the function f of x equals x cubed times sine x minus 2. So here, I notice that I have a product of functions, so I have to use the product rule when I take the derivative of this term in that function. All right, so derivative rule says if you have a product of functions, it is u, or the first function, times the derivative of the second, plus the second function times the derivative of the first. All right, so I'm going to go ahead and find f prime of x. All right, so I keep the first function, x cubed. Then I need to multiply times the derivative of the second function, so that is cosine x, plus the second function, which is sine x, times the derivative of the first, so that's going to be 3x squared. And then the derivative of -2 is just 0. So here is my final answer for that one. All right, this one is asking for the equation of the tangent line and the normal line to y equals 3 cosine x minus 1. And they tell us the input, or the x value, of the point that this tangent line is going through. So remember, in order to write an equation of a tangent line, you need to know the point that's on the line, and you need to know the slope. And the slope you'll find you have to find the derivative of this function right here. Now when it comes to the point, I know that the x value is pi over 3. So in order to find the y value, I need to take this pi over 3 and plug it in right here. So let's see, y then equals 3 cosine of pi over 3 minus 1. All right, so for the cosine pi over 3, I'm just going to go to my triangle just to show where I get this number from. Hypotenuse is 2. This is the 30-degree angle. This is the 60-degree angle. This one's the pi over 3. This one's the pi over 6. 6. All right, so the cosine of pi over 3, or 60 degrees, is the adjacent side over the hypotenuse. So that means that the cosine of pi over 3 is 1/2. And so here I get y equals 3/2 minus 2/2. Let's see. All right, so I get an output of 1/2. So I'm going to put 1/2 right here. So now I have the point that's on the tangent line. Now I need the slope of that tangent line, which is going to require me to find the derivative to this function here. So when you have a number in the front, so it's going to be 3 times the derivative of cosine, and the derivative of cosine is negative sine. So I'm going to put the negative here, and then the derivative of -1 is a 0. Now I need to plug in the pi over 3 in here so that I can figure out what the slope is at pi over 3, or at this point right here of that line. So let's see, y equals -3 sine of pi over 3. So pi over 3 is the 60 degrees, so that's going to be the opposite over the hypotenuse. So I get y equals -3 times √3 over 2. So there's my slope right there. So my tangent line is y minus the y value equals the slope times x minus the x value. So that's on that. And then the normal is all the same, just the slope is now the opposite reciprocal, and you do not have to rationalize. Yippee! And that's it, done.